All right, we're going to look at the last topic in this section 2.1. There's a lot we're doing here, but this last one I think is one of the more interesting things we're going to be doing. This is the idea of constraint optimization. And the idea is this. We have something we need to do, or some goal we want to achieve. We have to be careful though, there's a constraint. There's something that has to be met in how we actually do this. So there's many ways to achieve this task. Of all the multiple ways to do this, we want to know which one is going to either minimize or maximize some objective function. Now the objective function is also sometimes called the cost. So the idea is something I need to do. There's some constraint that has to be met, some restriction that has to be true. Out of all the possible ways to achieve our goal, we want to know which one is going to either make some cost the least or some benefit the most, depending on the context of the problem. Now, these basically come in the form of word problems, and they can be very difficult just to parse and understand what the question is. So what tends to be the most difficult part of these kind of questions is not the math and how you do it, but how do you approach the problem in a structured way and do so in a way that will help you achieve things in general. So how do we look at this in a way to look at these type of questions and know how to get through them? So I'm going to go through an example, but I'm going to focus on the steps that I'm taking in terms of understanding what I need to do rather than the math underlying it. Because this idea of problem solving is something that's going to be very important in general, not just in this course, but in many of the things we do throughout your education. Okay? So let's look at an example. And again, I want to focus on not the math or how we're solving it in terms of the equations. I want to focus more on the steps that we need to take in order to solve this question. Okay? All right, so I want to build a fence. And the fence is going to be used to keep my sheep in place. Okay, I've got 200 yards of fencing. And I like my sheep to be happy, so I want to get them close to a nice, happy flowing river, and I'm going to make a rectangle out of this fence, but I only need 3 sides of the fence because one side is going to be towards this nice river. Okay? So the question is, what dimensions should I use in order to get the largest area? Because I kind of like the sheep and I want them to be happy and have the largest area to play in. So there's many ways to do this. I could just lay it out very long and thin. I won't have much area, or I could make it very skinny and very wide. Again, I wouldn't have much area. So the question is where's the happy medium that's going to make my sheep as happy as possible? Okay. So the first step, this can be the most difficult, is to read the problem and understand what the heck is even being asked. So just recognizing that this is a constraint optimization problem can be difficult. So what do I have? I am given that I've got 200 yards of fencing, I'm going to make a rectangle. Okay. All right, now that's telling me that I don't have to cover everything. He's only going to be worried about 3 sides. Okay. And then I've got the question itself. The question itself is, what are the dimensions I'm going to use to do this? Okay. Notice it's not asking for the area, it's asking for the dimensions. It's an important point. To figure out what is the answer that we're looking for is some height and some width. Okay, and so now this idea that I've got 200 yards of fencing to make this, this is going to be the constraint that I have to deal with. I can't use more of that, and I want to use all of it because it's taking up a lot of wasted space in my barn, and I want to get rid of it, okay? And so I want to use all of this 200 yards of fencing, and that's all I can use. I can't use any more. So there's my constraint. The largest area, that's my objective function, or my cost. And in this case, I want the cost, or my objective, to be as large as possible. Okay, so now, the next step is to draw a picture. And this can be the most crucial part of this, because as it is, just looking at this, I'm not going to be able to just solve this. Right? I need to go through these steps, try to understand what the question is, understand what are the constraints and the cost function or objective, and see how they all fit together. The easiest way to do this is to draw a picture. So what do I have? I've got my nice flowing happy stream. Okay. And then, what do I have? I have my pen like this, and in my pen, I've got my sheep. Okay? So now the question is how do I go forward from here? So I've got my picture. My next step is figure out what my variables are. Okay? Be careful here. I have not been told what any of the variables are, what to do. So I need to define what I am working with. So I've got this side and this side and this side. Now notice, because it's a rectangle, this side has to be the same as that side. So let me call that W, let me call that H. So I've got some width and some height, and I've got to use those things to figure out what is going to be the area that's going to be the biggest thing. Okay? All right, so now my third step is figure out the relationships between all the variables that I have. Okay? So what do I have? I have the fencing that I'm using is almost the perimeter of this rectangle except for this part. Right? So I would just basically have this plus this plus this. Oops. Okay. So this plus this plus this, W plus H plus W, has to equal the amount of fencing that I have. Okay, so there's one relationship. Let me rewrite this. I got two W's here, so let me call this 2W plus H. Gives me that. Okay. The other relationship is what I have here, and this is the area. The area is just the width times the height. Okay. Now notice I've not solved anything, I've not figured out what I'm going to do or try to do anything, but I just got a bunch of relationships that I have to work with. Now notice this thing right here is an equation that has to be satisfied. This has to be true, so that is my constraint. This is what I want to be big, so this is my objective. And that's the thing I want to make as big as possible. So of all the values of W and H that satisfy that, so think about this, this is a straight line relationship between H and W. There's infinite solutions to that. of all those solutions, which one's going to make that as big as possible? Okay. All right. So now, what's my fourth step? My fourth step, again, I'm not just jumping in and trying to solve this because there's too much going on here. My fourth step is to make a plan and figure out what's the best way to do this. So here's what I'm going to do, is I'm going to solve the constraint for one of my variables, either h or w. Notice h doesn't have anything on there, so I'm going to solve it for h. I think that's going to be a little easier. Sometimes it's not, sometimes you get fooled, that's okay. Just make a decision and go with it. So I'm going to solve that equation for h. I'm going to then substitute that into the objective function, and once I do that, I'm going to find the vertex. Okay? Now I'm running out of room here. I'm going to have to erase some stuff. So I'm just going to state the next two before I do them. The fifth step is basically carry out my plan, figure out what I need to do. And one of the more important steps, one that often gets overlooked, is the last thing you use, go back and check your work. Okay? All right, so I'm going to do this in just a second, but I just want to recap these 7 steps. First thing is read the question, understand what's being asked, draw the picture for the next step. Again, this is a crucial step in trying to understand what's going on here, because this can be very confusing and hard to figure out what's going on. Once I do that, I have to define the variables that I'm going to work with. Those are never really given to you, and it's up to you to decide what they are. The next thing is to figure out what are the relationships that tie things together. In this case, there's only 2 relationships. One is the constraint, the amount of fencing I have has to add up to 200 yards. The other thing is the objective function, the area. This is the thing I want to either maximize or minimize. In this case, I want this to be as big as possible. And notice I'm still not jumping in and trying to figure this out. There's still too much going on. So I got to figure out my plan. So my fourth step is to decide what I'm going to do. Here I'm going to take my constraint, solve for h. That's the first step. Second step is to substitute it into here. And then once I do that, I'm going to try to figure out what value of w will make this as big as possible. Okay? And that's going to be finding the vertex in this particular case. And the only reason I know that is because I've worked this out in advance. Fifth step, second to last step, notice, is you actually go through and do the steps. And the last thing to do is check your work. All right, so let me erase this and focus on this. And again, I can't stress enough I didn't just jump in and try to solve this, right? I had a set of steps that I went through to try to tease out what's going on, which allows me to bring it down to here and just focus on this. So I have 2w plus h equals 200. I want to solve that for h and then substitute it back into my area. Let's see, so if I subtract 2w from both sides, get that. And now for my area, this is going to be w times h. But my h I just decided is that, which is this thing. So let me distribute the w. So I get that. And now I have a parabola. My area is equal to that. And I want to figure out where's the vertex for this parabola. So let me rewrite this. So my leading order term is up front. Oops, I got that wrong. Be careful, that's minus 2 plus 200w, and that's what I'm going to work with. Now, before I go through and do it, I want to ask, does this make sense? Notice this is a parabola. So now my w is the independent variable, and for any given w I get an area. Because that's negative, and notice w is a root, I claim my area looks like that, and I'm only going to worry about positive values for the area. So the question is, where is that vertex? Okay, now to do that, I need to factor out the -2, the leading coefficient for that. 200 divided by -2 is -100. And now I'm going to complete the square to figure out what's going on there. So let's see, complete the square. I can never remember what that is, so let's see. I want this whole thing to look like that. There's my w squared, so that's fine. And now for this term, first order term, my -100w has to equal that. So -100w has to equal -2aw. This has to be true for all w, not just w equals 0. So I can divide through to get rid of that. I can divide both sides by -2. So -100 divided by -2 is 50. So my a is equal to 50. Okay. So that means I need to add and subtract 50 squared. So if I do that, so I add 50 squared, but then I have to subtract 50 squared. This right here becomes w minus 50 quantity squared, okay, minus 50 squared. I multiply through by the -2. Get that? So what does this say? This says that in order to maximize the area, my w has to be 50. The maximum area that I'm going to get is going to be 2 times 50 squared. So let's rewrite all that. But unfortunately, I'm not quite done. The original question is, what are the dimensions, which is plural, so I also need to figure out the h. So I come back to here, and I got to figure out what is the value of h when w equals 50. So I plug in w equals 50 here, multiply it through the 2, and I get h equals 100. I gotta be careful, these are in yards, okay? So if w equals 50, h equals 100 yards, then I will get, these are in square yards. Okay. I'll get an area of 2 times 50 squared yards, and I'm claiming that's gonna be the maximum, because my area function looks like this. It's a parabola going downwards, and I know the vertex. And so I've now completed the steps 0 through 5. Step 6 is to check my work. And what am I going to do for that? Well, I'm going to go back and watch this video again and see if I made any mistakes. And if I did, you need to let me know. Okay?